Well, welcome to Math 3C. My name is Greg Perkins. I will be your host. Today we're going to be looking at section 12.1, which is about graphing in 3 dimensions. So in order to graph in 3 dimensions, we're going to be using this free website, geogebra.org. I guess it's geometry, algebra. They mashed the two words together and got geogebra.org. So I'm going to show you that in a few minutes, but let's do a little bit of math first. The distance formula. Hopefully, in pre-calculus, you did the distance formula with 2 points, x1, y1, x2, y2. Here's the distance formula. Subtract the x's, square it, subtract the y's, square it, add those, take the square root. Well, I'm starting here because not only do you need the distance formula in 3-dimensional calculus, but I also wanted to point out, look at how similar it is. It's basically the same thing, except in 3 dimensions, you also have the z value, which means go up or down. And you just add that into the formula. Z2 minus Z1 is squared. There's the distance formula. Let's try it out. So find the distance between these 2 points. So whenever you have an ordered triple like this, it's going to go in alphabetical order, X, Y, and Z. And let's just do the formula. So you go ahead and subtract the 2 X values, square that, the 2 Y values, the 2 Z values. Now the order doesn't matter, but you do need to be consistent. So here I went the second one minus the first one. Okay, so this is going to be negative 5 squared is 25, 5 squared is 25, and 6 squared is 36. That'll be the square root of 86, or 9.274. Now let's go over to GeoGebra. So when you first go there, look for this 3D calculator. They've got a bunch of calculators, but we need the 3D calculator. So you click on that, and it's going to look like this. And so you can just put in your information over here. So I'm going to say point A equals parenthesis 2, comma 3, comma 4. Notice that when I started typing it, it will start to make the point because it's basically trying to guess what you're talking about. Anyway, then when I hit enter, there's point A. And point B is equal to negative 3, comma 8, comma negative 2. So there we go, point A and point B. Now before we find the distance, some things I want to point out. For some reason, this got turned around. There we go. Okay. So for recording purposes, I'm using my laptop, and I'm not used to using the laptop. That's why that took me a little bit longer. But anyway, you can rotate it around. See this gray part right here? That is where z equals 0. You can even see a little blue 0 right there. So when z equals 0, that's the xy plane. So that's this gray part. So it's like this is underneath the floor and this is above the floor. Now, how do you find the distance between them? Well, if you look over here, there's 2 icons. One is for typing in equations, like I was just doing, and then this tools icon. And right now they only show you some basic tools, but if you just click more and scroll down, eventually it's going to say measure. There we go. So now find the distance. So I just click on that and then say from point A to point B, and it says that it is 9.27. I was trying to see it a little bit better, but it does say 9.27. All right, now let's do something else. So I'm going to go ahead and just delete these right here so that we can do the next one. So for the next one, hopefully you remember how to complete the square. So with this plus 9 right here, we're not able to factor it. So you move the 9 over. Then you take the b, the number in front of x, you cut it in half, which would be 2. Then you square that, which would be 4. So then you add in 4, and then you subtract it back out. Basically, you're borrowing $4 from the 9 and moving it over here into your account so you could then factor this, which factors into a perfect square. So for this one, the vertex would be x equals -2 and y equals +5. So whenever it's in the parentheses and squared, you actually use the opposite of that number to find out what the x-coordinate would be. What about this one? Find the center of this sphere. So in pre-calculus and even Math 3A, 3B, if you have x squared plus y squared equals a number, then that is a circle. Well, if you have x squared plus y squared plus z squared equals a number, that is going to be a sphere, like a basketball or a golf ball, whatever sport you like. When it's got this extra 2x and this 10y, that's going to change the center. So that's going to shift it around. So what we need to do is, first of all, I take the x information and just move that over here, leave a blank. The y information, group it together and leave a blank. And then there is no extra z information, so that's just going to stay z squared. And then do the completing of the square. So right here, this 2, you cut it in half, that's just 1. Squared, that's just 1. So add in a 1 to both sides of the equation. Right here and right here. Take the 10, cut it in half and square it, that's 25, so add that to both sides. And then you can factor. So for the x's, it factors as x plus 1 squared. For the y's, it's y plus 5 squared, and z squared just stays that way. So that means that the center is at -1, -5, 0. And the radius would be the square root of 34, which is 5.831. Now I want to check my answer by going to the three-dimensional graph. So what I'm going to do is type in the original equation, which was x squared. So I just put the up arrow for squared, and then plus y squared. And like I said, as you go along, it will graph as much as you've typed, but you could just ignore that and just concentrate on the typing, which I should take my own advice. And then z is squared, and then there was an extra plus 2x and plus 10y, and at the beginning it equaled 8. So we get this sphere right here. Let me shrink it down a little bit. So there's the sphere. But I want to make sure that I got it right. So I'm going to graph the center. So I'll call that point A, and equals. So for the center, I got -1, -5, 0. And that point, it looks like it is in the center. Now I need some mathematical way to see if I actually got that right. Well, the radius was the square root of 34. So if I go from the center and I go straight up to the top, that point right there should have a z value of square root of 34. So in other words, leave the x value alone, leave the y value alone, because I'm not going to go this direction and I'm not going to go this direction. I'm only going to go straight up. So if I did it right, this point right here, where I leave x alone and I leave y alone, and then I put the square root of 34. So that was, as a decimal, 5.831. And then that point should be sitting right on the top. And that definitely looks like it's sitting right on the top. If you get to the side of it, you could see, yep, That looks like it is right on the top, and it's right above point A. Okay, so now let's do something slightly different, and that is take a look at the homework. So this is what the homework looks like for me on my math lab or my lab math. And these are the questions that I assigned for your homework. And I actually went through each and every possible question. I looked at them and I added them one by one. It's a detail you don't really need to know, but what I'm going to do now is I'm going to look at one that I actually assigned you, which was number 11, and then I'll pick a similar one, number 9. Let's see what they say. Hopefully my internet's going all right. Give a geometric description of the points in space whose coordinates satisfy this equation. X squared plus y squared plus z squared equals 25. That's pretty easy. That's a sphere, and the radius is 5. But they also say x equals 0. So x equals 0, what's that? Well, what I can do is I can even use this one and just keep the x squared plus y squared plus z squared, change this to 25. That is now a sphere of radius 5. Delete this, delete this. And then they said also x equals 0. So x equals 0 is this plane right here. So it's the blue plane. And x equals 0, so this red axis is the x-axis. And they're saying x is equal to 0. So you don't go out along the red axis. You don't go back in the negative red axis. But once x is 0, then y could be anything and z could be anything. So this blue sheet right here is called the YZ plane. So whenever it talks about a plane and it says the YZ plane, the letter x was left out. That means x equals 0. So if it said the XY plane, z is left out. That means z equals 0. Okay, so where do those intersect? So basically, if you take a basketball and you take a piece of paper, or actually you would need something a lot sharper and harder than that, like a knife, and you just cut it, then it's going to leave this circle that has a radius of 5. All right, now I think I can answer the homework question. Uh-oh, it disappeared. So because I have the teacher's version, it already tells me the answer. That's sort of a ripoff, but I can't do anything about that. So the circle y squared plus z squared equals 25 in the yz plane. So simply because it said x equals 0, then I know that's the yz plane. Also, by looking at it, I can see that it was a circle. So I'm pretty sure that it's part A. But even with this, you can test that answer and go ahead and graph y squared plus z squared equals 25. So I can leave this information here, just hit enter, and then put y squared plus z squared equals 25. Now, that's basically it, except I have to restrict it to where x equals 0. So y squared plus z squared equals 25. That actually makes this right circular cylinder, basically like a soda can. And you have to pay attention to it's also where x equals 0. So then that would be, again, this circle right along the outside of the original sphere. Shall we look at another one? Let's see. So this says number 23. So how about number 25? Describe the plane perpendicular to each of the following axes. Okay, so I was hoping for a more challenging one, but so it's giving you this point, 9, -9, -3, and then it's a plane that's perpendicular to the z-axis. It says that the answer is z equals -3. So what I'm going to do is just go ahead and graph this point and see what they're talking about. So a plane, I might have just said parallel. It's supposed to be perpendicular. So 9, -9, -3. So let me erase this. Okay, so put a equals 9, comma, -9, comma, I think it said -3. So that's this point down here. And now, what happens with z equals -3? So that point is in that plane, and the blue axis, this is the z-axis, this plane is perpendicular to it. So that is what they were talking about. So with this GeoAlgebra, I think they pronounce it GeoGebra. Anyway, with the GeoGebra, it's free and it can really help you out in visualizing what's going on in this class, especially at the beginning when there's these new shapes and things like that. Let me show you just one more example. I keep hitting duplicate instead of delete. Okay, what about a parabola? Remember from pre-calculus or first semester calculus of parabola? Y equals x squared. Y equals x is squared. So y equals x squared, well, that is a parabola, but now it's in 3 dimensions. Now, basically, with this equation over here, it doesn't say anything about z. So z could be anything. So that means when z equals 0, which would be this part down here, when z equals 0, it's a parabola. When z equals 6, up here at the top, you make another parabola. When z equals 5, make another parabola, etc., etc. So basically, this is just a bunch of parabolas that have been stacked on top of each other, going up forever and down forever, the z-axis. So this is called a parabolic sheet. Like if you take a sheet of paper and you fold it, where are you? There you are. And you fold it until it looks like a parabola, that's a parabolic sheet. And if they talk about the inside of the parabolic sheet, that would be this part. Like if it was a taco, you would fill it on the inside like that, and then this would be the outside. Okay, so hopefully that was a good start on section 12.1. Please let me know if you have any questions.